Hello. Hello. I welcome you back to this YouTube channel, Marine Education Services. And this session is suitable for students in Senior 3 and Senior 4. If you are not falling under the mentioned category, kindly look for videos that align with your levels. So I want to illustrate something here to make sure that share entire screen here. Make you believe that these things can be understood in very basic terms. Now for ionic bonding, this is what we are saying. Ionic bonding, we are saying that I want us to go very slowly. This is an example. I don't know whether I can write this thing. Let me see. Does it have options for writing in it? It is not having. Not having. I thought it has. Edit. I think it is. Yeah. On my screen is visible. Very good. So you can see that here we have transfer of electrons. That is how an ionic bond is formed. Transfer of electrons from a metal to a non-metal. For example, this is an example of a metal, sodium. This is an example of sodium. Sodium has, it is element 11. It is element 11 with electronic configuration 2 to 8 to 1. Electrons in the outermost shell. That's why you see here, I only have the outermost shell here. So my A here is sodium. I represent the outermost shell. For simplicity, kindly take note of that. You only represent the outermost shell. And electrons are filled one by one like that. So you see sodium has one electron which it transfers to. Now this is chlorine. Chlorine has, it is element 17 with electronic configuration 2 to 8 to 7. The outermost shell has 7 electrons. We have 1, 2, 3, 4, 5. No, however, that's not how we should fill them in. Sorry. I cannot, okay, I think I can. I cannot wrap. Yeah, but electrons are filled one by one. They are filled one by here. The outermost, I was saying that the outermost shell of sodium has of chlorine has 7 electrons. So you see, this is how we write them, right? 1, 2, 3, 4, 5, 6, 7. One by one. Yeah, there's a reason as why I'm emphasizing that. Please don't fill them like this. 1, 2, 3, 4, 5, 6, 7. However much, for some cases, it may not change, but desist from that. Those are some of the mistakes which you always make. Kindly don't do that here. Fill one by one. So this is chlorine. So my B is chlorine. So it's like sodium loses electrons to chlorine. So once sodium loses electrons, now it is left empty. That's why we have A plus. When it loses electrons, it becomes positively charged. And this is chlorine. Chlorine, when it gains electrons, it becomes negatively charged. So that is ionic bond. Allow me stop sharing this. So meaning that the force of attraction which binds A and B, sodium ion and chloride ion, is what we call an ionic bond. Then What else? The giant ionic structure. This is the giant ionic structure. It has disappeared. See? What did we say? Look at what you have for giant ionic structure. We said that the giant ionic structure consists of the structure, it is here. Type of structure consists of large number of oppositely charged ions. Remember, we have seen that a metal loses electrons to form positive ions. A non-metal gains electrons. Oh, a metal loses electrons to that non-metal, so meaning that the non-metal gains electrons to form negative ions. Yeah. So you have a structure made up of oppositely charged ions, ions of opposite charges. So this is what I am referring to as a giant ionic structure. Now this is the structure of sodium chloride. It has, I think I'm not good in colors. Over this is purple. Yeah, there is this one that has Na plus. There is this one. What is this? Now we have gone back to the other one. Sorry. Is it here? There is that one in purple. Hope it is correct. You may feel free to correct me if it's not purple in the chat. Am I on? Am I on? Yeah, I am on. Yeah, so that is the giant ionic structure. These lines you are seeing, can I edit? Edit, where are you? These lines which you are seeing here, this white line, the white line, that one, joining Na plus to Cl negative, the white lines, those are what we call the ionic bonds. Those are the ionic bonds. So this is the ionic bond. And this is the giant ionic structure. So allow me to stop sharing this. Then I share another type of structure. A covalent bonding. A covalent bonding involves sharing of electrons. We saw that it involves sharing of electrons between atoms of non-metals. For example, in this case, I am illustrating formation of, this is formation, edit. This is formation of chlorine gas. Formation of chlorine gas. Chlorine gas is Cl2. So it comes from chlorine and chlorine. So this is one chlorine, this is another chlorine. This chlorine here is element, chlorine is element 17. It's element 17. Yeah, it has electronic configuration 2 to 8 to 7. Also, this has electronic configuration 2 to 8 to 7, like that. So there are 7 electrons in the outermost shell. Hope you still recall how I told you to fill in these electrons. Yeah. So you see here we have arrows interchanging, meaning that they share, each one contributes, each atom contributes, so that you have this. So you represent them by intersecting, joining the two circles to show that there is sharing of electrons, like that. I hope that is understood. Which other one? Covalent bonding results in formation of two types of structures. There is the simple molecular structure. See, this is now the simple molecular structure in water. This is the simple molecular structure. Recall that the simple molecular structure, my screen is failing to share. I think it is here. Recall that the simple molecular structure consists of molecules joined together by van der Waals forces of attraction. Consists of molecules joined together by van der Waals forces of attraction. So these are the molecules. I am taking an example of a covalent compound, water. This is how water looks like. This is how it looks like. It is H2O. Edit. Water is H2O. It is H2O. You have oxygen with 2 atoms of hydrogen. You have oxygen with 2 atoms of hydrogen. Yeah. So oxygen with 2 atoms of hydrogen. Those molecules. Now this is one molecule, but you cannot count water. You all agree with me that water is uncountable. Maybe you can measure it in liters like that. Yeah, but we have very many molecules. We can also maybe determine them using Avogadro's number. Yeah, things to do with that. But basically they are uncountable. So you have many molecules of H2O, joined together by weak intermolecular forces of attraction. And those weak intermolecular forces of attraction have a name. They have a name. The one which I called the van der Waals forces of attraction. So for English purposes, they are known as weak intermolecular forces of attraction. But for purposes of chemistry, they were given a name, van der Waals forces of attraction. Yeah. So basically, if I say this is the simple molecular structure, I am meaning that type of structure. Yeah. So you can have many molecules. Like for the other case, we have seen chlorine. Chlorine, another example one can say for chlorine, you have, this is what we are having. This, for the other previous example, we have demonstrated chlorine molecule. You have Cl. So this is one chlorine. So it joins with another one. Like that. It joins with another one. Like that. So the process of joining continues. And these lines, the dotted lines you are seeing, those are what we call the weak intermolecular forces of attraction. So this type of structure is simple molecular structure. Finally, we have not finally, sorry. Now this is the giant covalent structure. Here I have covalent compounds. In senior 2 under carbon in the environment, you looked at the structure of diamond. You looked at structure of diamond, and this is how it looks like. Yeah. It is made up of carbon atoms. By the way, diamond is carbon. So you link many carbon atoms like that. You link them exhaustive. Come up with that type of structure. So within the giant covalent structure, you have atoms. Look at these atoms. Hope you still remember my description. I said that for the giant covalent structure, you have atoms. Atoms joined together by covalent bonds. Kindly don't forget this. Giant ionic structure, what do you have? Giant ionic structure, you have ions joined together by ionic bonds. I repeat, giant ionic structure, you have ions joined together by ionic bonds. giant ionic structure, you have ions joined together by ionic bonds. Then simple molecular structure, you have molecules joined together by weak intermolecular forces of attraction known as van der Waals forces. Then giant covalent structure, you have atoms joined together by covalent bonds. Now this is diamond. Also this is graphite. Graphite has atoms. They are here, atoms which are being joined together by covalent bonds. However, graphite is layered. That's why you have a layer down and a layer up. Then this is sand. This is sand, silicon dioxide. Silicon dioxide is made up of silicon atoms and atoms of oxygen. They are also linked up by covalent bonds. Yeah. So giant covalent structure, you have atoms linked together by covalent bonds. Yeah. Now here we may not write these things because your teachers have really done a nice job of explaining these things at school. Yeah. However, for me, I'm just giving an introduction, things I need before I work out some items. Yeah. However, you can as well note them down. Lastly, finally, metallic bonding. Metallic bonding, we saw that. Recall that. Maybe I remind you a little bit. Metallic bonding is here down. You see, metallic bonding involves interaction between metal ions and their valence electrons. And I gave an example of sodium. Sodium in its outermost shell, it loses one electron to form sodium ion, and that electron which it has lost. So the interaction between sodium ion and the electron which it has lost is what we call metallic bonding. So that's why here we have the giant metallic structure. Giant metallic structure takes this form. Like that. So you have sodium ions. You see, you have sodium ions, and these sodium ions are surrounded by electrons. These sodium ions are surrounded by electrons, like that. Yeah. So that is the giant metallic structure. Giant metallic structure, one can also say that it has atoms of metal joined together by metallic bonds. Atoms of metal joined together by metallic bonds. Yeah. As of now, allow me first stop here.